All right, guys, we're going to go through our last electron configuration notation for this unit, and that's Lewis electron dot diagrams. Okay, so this is our last electron configurations. This is probably the easiest one. All right, so Lewis dot diagrams show only the valence electrons. So valence electrons, what are valence electrons? We've talked about this, I believe. Valence electrons are the electrons in the highest energy level. Our kernel electrons are all of the electrons that are in any lower energy levels. Okay? So we're only going to care about our valence electrons. So the first thing that we're going to do is we're going to write our element symbol. This allows us to know which atom we're thinking about. Then we're going to add the electrons that are in the s and p orbitals together, because those are the only electrons that are in the highest energy level. All of the electrons that would be in a d or in an f orbital are going to be in a lower energy level, right? If we remember something like iron, you guys should have used our iron example before. Iron, we fill in the 4s electrons, which would be 2 electrons, and then we go and we drop down into the third energy level, d orbitals. So if we're filling in the d or the f orbitals, we only have our s orbital electrons that are in the highest energy level. The d and f orbital electrons are filling in lower energy levels. So when we make our Lewis electron dot diagrams, we only care about the s and the p orbital electrons. Okay? Then, once we know how many electrons we have, we use our dots to represent those electrons. Okay? So we're going to go through an example here with neon, and then we'll do another couple of examples. First of all, neon, if we go look at neon, we have 10 total electrons. Okay? So 10 total electrons, and our electron configuration, we've done this many times, would be 1s2, 2s2, 2p6. Our highest energy level is the second energy level. We remember when we write the electron configuration, this first number is our energy level. The 1 with the 1s2 is a lower energy level, and those would be our kernel electrons. So we have 8 electrons total that we get to put onto our dot diagram. So the dot diagram, we're going to write our symbol first. That would be neon. Then we have 8 electrons that we get to place on our diagram. When we place our electrons, we're going to go and we're going to place them in 4 different places. Okay? So we have the top, we have the right side, we have the bottom, and then we have the left side. After we have hit our 4 locations, then we go and we pair them up. And I like to make sure that they are nice and close to each other so that they are paired together. Okay? So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay? So, with our Lewis dot diagrams, like I said, we really only care about our valence electrons. So the easiest way to understand our valence electrons and count our valence electrons is really just to look at our column on the periodic table. If we look at the periodic table, the column or the group that the elements are in tell us how many valence electrons they have. For the first group, elements in group 1, they have 1 valence electron, and they would have 1 dot. Elements in column 2 will have 2 valence electrons and would have 2 dots. Elements in column 3 through 12, these are filling in the lower energy level d orbitals. So we don't really care about all of those d orbital electrons. We only care about the 2 electrons that have been filled in the s orbitals. So they only have 2 valence electrons and would have 2 dots. Then when we hit column 13, so this would be boron, aluminum, gallium, indium, elements in column 13, they have 3 valence electrons. 2 electrons that would be in the s orbital, and 1 electron that would be in the p orbital. So they have 3 valence electrons, they'd get 3 dots. Column 14, 4 valence electrons, 4 dots. Column 15, 5 valence electrons and 5 dots. Column 16, 6 valence electrons, 6 dots. Column 17, 7 valence electrons and 7 dots. Column 18, 8 electrons and 8 dots. So if we have our periodic table, which you guys always have, we will be able to understand how many valence electrons we have for each element. Okay? When we have ions, when we have ions, what we actually have to do is we just need to adjust the number of valence electrons. Okay? And this then will match the charge of the ion. So this charge of the ion, right, with our new valence electrons should match our dot diagram. Okay? When we do that, we do also need to add a couple of things. So let's show an example maybe of, let's see. Let's do fluorine. Fluorine, let's go ahead and do just our starting example here with fluorine. So fluorine atom, we would have 7 valence electrons because it's in column 17, right? So we're halogens here. We have 17, or group 17, we have 7 total electrons as our valence electrons. We would show 1, 2, 3, 4. Then we pair them, 5, 6, 7. When fluorine becomes an ion, it actually gets a -1 charge. So if it is a -1 charge, we would get 1 more electron. We would put the square brackets around it and then show a 1- charge here. Okay? So if we had F -1 as our example, we would need to show our Lewis dot diagram just like this. Okay? So we're going to go ahead and we're going to practice here. When we practice, we can go ahead and we can work with others. Okay?